Alright, so now I'm going to introduce two new lines that involve a circle. So the first one is called a secant. You might know this as the reciprocal of sine, but in this case, the secant refers to a line that passes through a circle at 2 points. Now, you may remember that a chord is a line segment that passes through a circle at 2 points, but a secant is a line. So basically, a secant is a chord infinitely extended. So a tangent is a line that touches a circle at 1 point, but does not pass through the circle like a secant does. Also, a pretty useful point about tangents is that a line drawn from the radius directly to the tangent makes a perpendicular line with the tangent. Alright, now I'm going to introduce to you Secant-Tangent Theorem. Now, the Secant-Tangent Theorem states that if I have a circle here, and I have a secant, and I also have a tangent, now let A be the point where the secant and tangent intersect. And now let B be where the tangent and the circle touch. And now let C and D be the points where the secant intersects with the circle. So C and D. So the secant-tangent theorem states that AB squared is equal to AC times AD. Now notice that it's AC times AD, not AC times CD. So now let's try it with a few numbers. So for example, let's let AB be equal to 10, and let's let AC be equal to 5. And so, by the secant-tangent theorem, we have that 10 squared is equal to 5 times 5 plus x, such that x is equal to CD, because 5 plus x is equal to AD. So now 100 is equal to 5 times 5 plus x, 100 is equal to 25 plus 5x, 75 is equal to 5x, and x is equal to 15. And so the length of AD is equal to 20, and CD is equal to 15. Alright, now let's get into some problems. Alright, and now our problem is now above me. So first, we know that E is the midpoint of AB. And so, AE is equal to BE is equal to 5. So, 5, 5. Also, BC is equal to 10. And so applying Pythagorean theorem, we know that EC is equal to the square root of 5 squared plus 10 squared, which is equal to the square root of 125, which is equal to 5 roots 5. So EC is equal to 5 roots 5. So now let's apply secant-tangent theorem. Well, we know that BA is tangent to the circle, and also that EC is a secant of the circle. So now let's call the intersection of CE with the circle to be F. So now we know that BE squared is equal to CF times CE by the secant-tangent theorem. Well, actually CE is equal to EC, just to keep my solution a little bit more clear. And so BE squared is equal to 25, which is equal to CF times 5 roots 5. Now notice that CF is the portion of EC which lies outside of the circle. So CF is what we are looking for. So now we have 25 over 5 roots 5 is equal to CF. And so CF is equal to 5 over root 5, which is equal to 5 roots 5 over 5, which is equal to root 5. And so root 5 is our answer, and we are done. Okay, so thanks for watching. Hopefully you enjoyed, and hopefully I'll see you next time.